So they want us to graph this equation. We're going to do it in a couple ways. So first off, we're going to do it the way we should really do it. The way we should do it is we know that all of these equations are in the form, or linear equations. The basic linear equation is in the form y equals mx plus b, where this number right here is the slope, and this number right here is the y-intercept, where it intersects with the y-axis. And that's really the best way to do it. So we see here the y-intercept is 5. So that means we have this point right here, 5 on the y-axis. And then the slope is 2. So what is the slope? We think about the slope as the rise over run is the quick way to say it. But really it's how much the y changes whenever the x changes. So here it's not like a fraction, but we can make it a fraction, right? Because any fraction is always just over 1. Any number is just always over 1. So this slope is 2 over 1, which means the rise is 2. So often you'll count that by going like 1, 2. You're going up 2, and then over 1. And that's going to be your new point. And then similarly, I think it's nice to do a point the other way. And you can just do it by following the pattern. You just see how it has to be on a straight line. But you can go down 2 and then the other direction 1. And see how those points end up on a nice straight line. And that's really the best way to graph a line, is you put it in, we have a name for this. We call this slope-intercept form. You see, we call it that because it gives us the slope and the y-intercept. And so then we plot the y-intercept and we use the slope from there, and there we go. But let me show you how you can always graph a line. If you don't know what you're doing, what can you always do? You can always plug in values. So like somebody in the comments said they had a test on tables and graphs. Well, you can always make a graph by using a table. So like we can say if x equals 0. If we plug in x equals 0 to this equation, 2 times 0 plus 5, you get 5. And that's the point 0, 5 right there. And you do a few more. If x equals 1, 2 times 1 plus 5, well, you see that's 7. And so you see that's the point 1, 7 right there. And we can do that for any value. Let's maybe throw out a wilder one. What if we did like -5? That's not even on our graph yet, but we can still see what that should be. So we're going to do 2 times -5 plus 5. So -10 plus 5. Very interesting. That's -5. So that's the point -5, -5. And so let's see if that looks like it should be on the graph. Right there. I think you got to admit, if you connect those, yeah, that point should be on that line if we extended it out. So this is like how you should be graphing lines. And whenever you think about the graph of a line or the equation of a line, this is what you should be thinking about. But worst comes to worst, with any graph, any equation you have, you can always plot points. And that's not some like cheater method. I do that all the time. When I don't know what any graph of an equation is going to look like, you plug in x values and you think about what's happening and you see the pattern, and then you can know what the graph looks like. Of course, if you have a graphing calculator, all this is out the window, but we're assuming you don't.